So what happens if they start asking you to balance the redox reactions in basic solutions? So luckily acidic solutions were used the exact same way as we've done before. But if we're dealing with basic solutions, we have to add a few more steps. So in step 7, we neutralize the H plus ions by adding the same number of OH ions to each side of the equation. And then we combine those H and OH ions on the same sides to make water molecules. And then we just cancel out water molecules on each side. And then we go back and verify all the atoms and charges are balanced. So I'll show you an example of this. Example 19.4 says balance this reaction in basic solution. We're not really changing any of the initial steps we went over. We're just adding a few steps in the end because we can't have H plus left over because that would mean it would be an acidic solution. So step 1 means balance anything that's not a hydrogen or an oxygen. That would just be chlorine for this problem because everything else is a hydrogen or an oxygen. So if I look on the left-hand side, we have 1 chlorine, and on the right-hand side, we also have 1 chlorine. So that's the easy step. We don't no longer have to balance it, it's already balanced. Step 2 says identify the oxidation states for each molecule. So H2O2, normally we start with the oxygen, but we're going to start with the hydrogen for this problem. Hydrogen always has a charge of +1, and there's 2 of them, so the overall charge will be +2 on the bottom. So for this to be a neutral compound, the overall charge on the oxygens has to be a -2. So each individual oxygen will have a charge of -1. For ClO2, we're going to start with the oxygens. There's going to have a charge of -2 for each one individually for an overall charge of -4. So the chlorine has to be a +4 for this to be a neutral compound. And then ClO2 minus, so that overall charge is going to be a -1. So if each individual oxygen has a charge of -2 for an overall negative charge of -4, that chlorine has to be a +3. And then if anything's by itself, like O2, the charge is going to be a 0. So let's identify what is being reduced and what is being oxidized. So we have 2 things that we can pick because hydrogen is only on the left-hand side. It's neither being oxidized or reduced just yet. So let's look at both oxygen and chlorine. So we have oxygen is going from a charge of -1 to a charge of 2. Or sorry, to a charge of 0. There's just 2 of them. That's where I got the number from. So in order to have this all balanced, I think this is O2, but if oxygen is going from a -1 to a 0, that means it's lost 1 electron. So that'd be E minus. And then let's look at chlorine. So chlorine is going from a +4 to a +3, meaning that it has gained 1 electron. So plus E minus. Also, we need to go back and balance the O2 because there is a 2 right here. We have to make sure that there is a 2 up front here for the overall electrons to be 2. Now, that also means that for every 1 electron of chlorine being gained, we're losing 2 electrons of oxygen. So I have to go back in and multiply those chlorines by 2 so at least the electrons will match. So my new equation will have those 2's out front of those chlorines, so at least the electrons on both sides are equal to each other and it's balanced. Next, we're going to make sure the oxygens are balanced on both sides. So let's look at the oxygen count. On the left-hand side, we have 2 plus 2, that would be 4. On the right-hand side, we have 2 plus 2, that's 4. So oxygens are fine. We do not have to add water to either side. Let's look at hydrogens. Well, there's no hydrogens on the right-hand side, and there's 2 hydrogens on the left. So I'm going to have to add 2H plus on the right-hand side for this to now be balance. But since we're in a basic solution, we have to actually continue because we can't just leave H plus in solution. So when they have that happen, we balance it with OHs on both sides to even this up, and we end up combining them to create water. So if I have 2 hydrogen on the right-hand side, I'm going to have to add 2 OHs on both sides to have that even. So now everything looks like H2O2 plus 2ClO2, plus 2OH minus becomes 2ClO2 plus O2 plus 2H plus 2OH minus. And so we then combine any H pluses and OHs in solution to create water. So we're going to just add plus 2H2O. So now when it says it's in basic solution, how do we know that? Well, the presence of those 2 OH minuses means that it's in basic solution. If you have just H pluses, that would mean it would be in acidic solution. So this would be the overall equation. All right, let's just double check all of our math. I'm going to just make sure our elements, our atoms are balanced. So chlorine, oxygen, and hydrogen. So there was a 2 out front. I forgot to include that. So there's going to be 2 chlorine on both sides. At least the chlorines are balanced. Oxygen. So 2 oxygen here plus 2, that's 4. Plus 2 times 2, that's another 4, so that's 8. On the right-hand side, we have 4 plus 2 is 6, plus 2 more is 8. And then hydrogen. So on the left-hand side, we have 2 hydrogen plus 2 hydrogen is 4. On the right-hand side, we have 2 times 2, that's 4. So all of our elements or atoms are balanced. Let's just double check the charges. So we have 2 times minus 2 plus 1, plus 2 times plus 1 plus 2 times plus 1 plus 2 times minus 1 plus 2 times plus 4 plus 2 times minus 2, or that's actually a 4. All right, got to figure that one out. And on the right-hand side, we have 2 times plus 3 plus 2 times minus 2 plus 2 times 0 plus 4 times plus 1 plus 2 times minus 2. So let's do the math on both of these sides. So on the left-hand side, I got a minus 2. And on the right-hand side, I realized I made an error. So I forgot to multiply the 2 to the 2 out here in front of the oxygen. So that would be a 4 times a minus 2. So when I've corrected myself, I have a negative 2 on both sides. So my atoms balance and now my charges balance. So this is going to be my balanced redox equation for a basic solution.